You are welcome on CMA Heights channel. Today we are discussing the CMA final stage, paper number 16. Paper name is Strategic Cost Management, and this we are covering this syllabus 2022 from the study note provided by the Institute of Cost Accountants of India. So first we will understand what exactly the structure of this new syllabus or new course. So this paper basically broadly divided into two sections, namely section A, which bears 60% of weightage in your examination, and section B 40% weightage is there. As far as the contents are concerned, section A is a mixed kind of some theoretical portion as well as the numerical portion or the problem based material, while this section B name is quantitative technique in decision making. It is basically purely mathematical kind of this things is there. So we first will try to cover your this second part, which is quantitative techniques, and this is so section B. We are on section B, quantitative technique in decision making. Let's move on. So first one topic is linear programming. In the earlier syllabus also we learned linear programming, but in the previous syllabus the linear programming was limited to the formulation of the linear programming problems. Here that the level of this uh, study is much beyond that the previous levels. So what exactly the linear programming? So to understand the linear programming, we have to keep our mind that we are the cost and management accountants. So what exactly our function is? Our function is to optimum utilize the resources available and to maximize the wealth or value, right? So in the practical world, what exactly we have to do? We have to work in situations where we have limited resources and we have objective to maximize the wealth or profit or create the values. To achieve this goal, uh, we will apply numerous mathematical techniques, and linear programming is one of them. So linear programming is basically we have to achieve some goals. You understand what exactly the basic construct of the linear programming. We have to achieve certain goals that will called our the objective function, keeping in the mind the constraint or the limitation of the available resources. So till now I used two words that achieve some objective, that is our objective function will be called in linear programming, and some limitations are there, they will be called as the constraint, right? So based on this philosophy, there can be a number of the definition of linear programming. So linear programming is exactly we have to basically obtain our objective. That objective could be a maximization of profit or minimization of cost, with subject to that certain condition that we have limited resources or the resources have the alternative use at that time. So in this linear programming, the basic components are the decision variables, objective function, and constraints. So don't bother about what exactly the definitions are. When we will formulate and solve the linear programming problems, we will naturally learn what exactly the definitions are, and we can easily write the definition if comes in our paper in our own language based on the our conceptual clarity. So that something that now we will move on the directly jump on the problem so that we can really understand what exactly linear programming is, how to solve it, and while I will be reading the your questions, I will explain all the related definitions so that you can understand with clarity and develop a thought process, and you can write the definition if comes in your paper in your own language or in a lucid manner or better manner. So these are some theoretical things. There are certain applications also mentioned in your study material, some industrial applications like the product mix. So mix could be that if suppose a company is making uh, multiple product using the same resources, then we have to optimize the our product mix, uh, how much a particular product should be produced to obtain or to achieve the objective function, right? So few illustration is there: production scheduling, blending problem, transportation problem, and so on and so forth. Second is the management applications, and this in the management applications they have the portfolio selections, financial mix strategy, profit planning, media selection, and so many. And there are certain few definitions like the form planning, airplane routing, diet problems, administrative functions, agriculture, environmental protection, urban development, and these are the facility locations or facility allocations also there. So these are the few area of application of the linear programming. How to formulate a linear programming? Some steps are there, but uh, I think when we will form a problem, we will automatically learn all these things. So we should not waste our time in reading all these things, right? So and further some definition again there. What are the decision variables? What the feasible solution, basic solution? So optimal feasible solution. I think we will when we solve our problem, we naturally learn all those things. So let us start our very first illustration of this topic, illustration 1. So I am reading this illustration 1, right? So a shopkeeper deals in two items: wall hanging and artificial plants. He has rupees 50,000 to invest and a space to store 100 pieces at the most. Cost of the wall hanging and the artificial plant are respectively rupees 450 and 200 each. He can sell a wall hanging at a profit of rupees 80 and artificial plant at a profit of rupees 37. Assuming that he can sell all the item that he buys, formulate a linear programming problem in order to maximize his profit. So this maximize his profit means a objective function here. Our objective is to maximize profit. Okay? But we have certain limitation. What are limitations? Only the shopkeeper has rupees 50,000 to invest. This is the one limitation or constraint you can say. and second is shopkeeper can store only 100 pieces at a time. So this is the second constraint, and these are the decision variable you have in fact uh, earlier seen in your definition. So these are the 80 rupees are the profit by selling wall hanging, and rupees 37 if shopkeeper can sell a artificial plant. What exactly we want? We want to maximize our profit. So we have three terms discussed. One is the objective function, second is the constraint, and third is the decision variable. So these are the three terms that is being used in this problem, right? So accordingly, I think you can now frame. I believe you have understand what exactly these terms are. So how to formulate this problem? So let suppose you may assume any variable here, x1 or x2 they have assumed. So it is up to your convenience to use x1, x2 or a1, a2, whatever you want. Suppose x1 be the number of wall hanging and x2 be the number of artificial plant that the dealer buys and sells. So that decision variable in this case is x1 and x2, right? So I x1 x2 attached with this become the objective function. Okay. So this this x1 be the number of wall hanging and x2 be the number of artificial plant that a dealer buy and sell. So the decision variable in this case are the x1 and x2, and how we maximize our profit, that is our objective function, is it is explained as the z is equal to 80x1 plus 30x2. 80x1 क्योंकि हमने x1 आपका क्या माना है इसमें, तो wall hanging. When we sell one wall hanging we will get 80 rupees as profit, and second is 37 rupees with selling an artificial plant. So we assume that these are our decision variable. We will sell buy and sell this x1 x1 wall hanging and x2 artificial plant. So this is our objective function and we have to maximize it. Similarly, total cost of buying of these items can be, क्योंकि one wall hanging cost is rupees 450 and one artificial plant is cost rupees 200. So 450 x1 plus 200 x2. So this is the total expenditure if the shopkeeper buys these two items in this basically this ratio or in this quantity you say. But what exactly this 450 x1 means wall hanging, x1 number of wall hanging purchase plus 200 of artificial plant purchase. So this total cost will should be, because we have rupees 50,000 only in our hand. So the equation will be like this. This will be 450 x1 plus 200 x2. It should be uh, less than or equal to 50,000. Simple, right? Okay. Only we have 50,000 in our hand to buy these items, right? Second is we have a space constraint here. We can only store 100 pieces. So again there is a space limitation and the shopkeeper can store 100 pieces at most. So x1 plus x2 it should be less than equal to 100, right? So this is the second constraint. This is the objective function, say equation 1. This is the this first constraint and this is the second constraint, right? this there is a space limitation we have already discussed. Now moreover, the x1 and x2 being are the physical quantity, there should be a non-negative constraint. Means the x1 should be always the equal or greater than zero. इसको बोलते हैं non negativity constraint. Or similarly x2 is again this greater than or equal to 0. So mathematical formulation will be, first is the, we have to what exactly, maximize, right? Maximize z means profit, because this equation will be 80 rupees by this selling x1 and 37 rupees selling x2. x1 is basically wall hanging and x2 is equal to artificial plant, subject to constraint, इन conditions के साथ, right? 450 x1 plus 200 x2 is less than equal to 50,000. This is the basically the money which we have in our hand, we can't invest more than this. And second constraint is x1 plus x2 is less than equal to 100, which is our space constraint, and x1 greater than equal to 0 and x2 greater than equal to 0. This is the non-negativity constraint. So this kind of the writing this like this is means formulating the linear programming. So in this illustration we have moved very slowly to understand each and every term, to develop our thought process or conceptual framework, so that while learning how to formulate the linear programming problem, we can also able to write some definition in our manner, right, if asked in the question paper, right? So